For the purposes of constructing modified box plots, outliers are defined as data values that are above Q3 by an amount greater than 1.5 times IQR, or below quartile 1 by an amount greater than 1.5 times the IQR, where IQR is the interquartile range. Using this definition of outliers, find the probability that when a value is randomly selected from a normal distribution, it is an outlier. Now, since we are looking for below quartile 1 and above quartile 3, we are looking for the 25th percentile and the 75th percentile. So we want to find z-scores for Q1 using the area to the left of 0.25, which is the 25th percentile, and the z-score for quartile 3 using the area to the right of 0.25, which is the 75th percentile, and then sketch the graph. So here we have our graph. So we're going to go ahead and then create our bell curve. Okay, and so currently we know that there's 25%, so that means that here we have this area to the left represents 0.25 or 25%. That is quartile 1. And quartile 1 is the same thing as the z-score that we want to find for that value. Okay, and then we also have the 75th percentile. So if everything from the left up until this point represents 75%, well then that means that this value over here represents 0.25. And therefore that represents quartile 3. Because anything to the left of this is 0.75. So if we take 1 minus 0.75, then that's going to give us this area to the right, which is 0.75. So we want to determine what is the z-score for that. So let's go ahead and shade those two. Okay, and so now what we want to do is we want to determine, we can use Statcrunch to find out what are those z-scores associated with Q1 and Q3. So we're going to open up Statcrunch. Okay, so the first thing we want to do is we want to find out, we're going to go to Stat, Calculators, and then go to Normal. And then what we want to do is we have a mean of 0, standard deviation of 1. We're pointing to the left because we want to find out first quartile 1. So we're going to put in the area that's to the left of that, which is 0.25. And then we're going to go ahead and copy that. Okay. So therefore, that's going to give us that z-score, or quartile 1, which is 25 in the 25th percentile. So if we round that to 2 decimal places, quartile 1 is going to be negative 0.67. Now keep in mind that since we're looking at a z-scale, that represents 0. But instead of saying z, okay, or z1, we're looking for quartile 1. Okay, now we want to find out what is quartile 3, which separates the bottom 75% with the top 25%. So let's come back up here now. My suggestion is to make sure you refresh. Okay, we want to make sure the mean is 0, standard deviation is 1, and now we're going to change this to be greater than or equal to, and then we're going to put in 0.25, because that means that this part is 0.25. So let's go ahead and copy that. And that gives us a z-score of 0.67. So therefore, we would say that this is 0.67. Okay, so now we know what quartile 1 is and what quartile 3 is. So, since quartile 1 is negative 0.67 and quartile 3 is 0.67, now we can find the interquartile range. Well, if you remember, the interquartile range is when you take quartile 3 and subtract quartile 1. Well, quartile 3 is 0.67, and then we're going to subtract quartile 1, which is negative 0.67. And so keep in mind that that is a plus, So therefore 0.67 plus 0.67 gives us 1.34. That's going to represent our interquartile range. Okay, next what we want to do is we want to find the quartile 1 minus 1.5 times the interquartile range. Well, we know that quartile 1 is negative 0.67, and then we're going to subtract 1.5 times the interquartile range that we found to be 1.34. So if we take 1.34, multiply it by negative 1.5, and then add negative 0.67, we get negative 2.68. So I'm going to go ahead and copy this here, down here. Okay, and so now what we're trying to do is we're trying to locate where this value is. So I'm going to go ahead and delete that z there, right? So we know that negative 2.68 is a little further to the left over here. So let's go ahead and draw that value. So that means we have a value here that represents negative 2.68. And so what we want to do is we want to determine the area now to the left of that. Okay? Now we want to find Q3 plus 1.5 times the IQR. Well, if we take 0.67 plus 1.5 times 1.34, multiply those two together and add 0.67, we get positive 2.68. So therefore, we would say that over here, it's going to be to the right of 0.67. So this is 2.68. And then what we want to do is we want to be able to find the area that's to the right of that value here. Okay, so now we want to find the area to the left of negative 2.68 and then find the area to the right of positive 2.68. So let's go ahead back into Statcrunch. We're going to select options and then select refresh. So we want to make sure we can find this part now. So we want to make sure it's less than or equal to. We have 0 and then 1, and now we're going to put in negative 2.68. Okay, so when we do that, we're going to get the following. I'm going to round that to 4 decimal places. So if we round that area to 4 decimal places, you're going to see that we get the following. 0.0037. So let's go ahead and put that in there. So this area here, and let's see here. So this area here is 0.0037. Okay, and now we want to go back and now find the area on the right. So again, we're going to select options and select refresh. Make sure that 0 and 1 here. Now we're going to change the inequality to be greater than because we want it to the right of positive 2.68. And so we should get the same area there, which again is 0.037. So we can see that that also gives us over here 0.0037. Okay, so now what we want to do is the percentage to the left of negative 2.6837, and the percentage to the right of 2.68 is 0.37. So let's go ahead and add those together. So if we take 0.0037 plus 0.0037, we get 0.0074. So we would say the total percentage is approximately 0.0070 or 0.0074, because that means if you add those together, that would represent that outlier. So we would say that it would be 0.0074 0.0074 as our result.